What's the most used man-made material on Earth? I'll give you the answer. Concrete. This is the Concrete Logic Podcast. Have you ever stopped to think about the sidewalks, driveways, bridges, or the buildings around you? They're all made from concrete. So why don't we discuss it more? In each episode of Concrete Logic, we'll explore a unique concrete-related topic with the help of industry professionals shaping the trade's future. We'll talk with suppliers, contractors, architects, engineers, specialists, and even proponents of competing materials. We'll get their views on concrete and their visions for its future. So get ready to mix things up with Concrete Logic, where we turn the spotlight on the material that's everywhere but often overlooked. This is the Concrete Logic Podcast. And now, here's your host, Seth Tandett.
Welcome to another episode of the Concrete Logic Podcast. And today I got Gary Brown from R.L. McCoy back with us, and we're going to discuss high-rise concrete pumping. And Gary, as he's our go-to expert on concrete pumping. He was on the podcast before, and I think we just talked generally about pumping, and this time we're going to tackle specifically high-rise pumping. But before we get started, just want to remind you all what you can do to help support Concrete Logic. You can go to if you learned something from the episode today, the first thing you can do is just share the episode, spread the word about the Concrete Logic podcast. The second thing you can do is if you go to the concratelogicpodcast.com website homepage, there's two ways you can get a hold of me. There's a contact button on the upper right, or you can look at the lower right. There's a little microphone. Either way, the contact button is like shooting me an email. The bottom right microphone thing is like shooting me a voicemail. And what we're looking for is topic or guest suggestions. So things you want to hear, things you want to learn about, please reach out and let me know. And then the third way is there's a donate button on the homepage as well. So if you feel like we provided some kind of value to you today, if it's worth some kind of dollar amount, you can donate to the show. And a new way that you can support Concrete Logic is we started the Concrete Logic Academy, which is a online community and educational platform that we've expanded the Concrete Logic podcast to, just to get folks that just want to discuss concrete things and not any of the other nonsense that we all had to put up with for it seems like forever. It was the last couple of years. There's a lot of other things going on in the world. But if you want to just to focus and sharpen your skills on just the concrete industry, I would implore you to check out concratelogicacademy.com. All right. I'm done with that. Gary, let's get into the good stuff. So Gary, last time we talked about pump safety for the most part, and I think what we want to talk about today is specifically concrete pumping for high-rise buildings which are tall and typically in an urban area, right? Very tight logistics. So there's some specialty there, right? So we want to discuss that. But maybe, Gary, if we could just refresh everybody on what is concrete pumping, and then a couple things, if you were just to introduce in about 90 to 120 seconds of what concrete pumping is. Let's do that first, and then we'll roll into specifically high-rise.
Concrete pumping is a device or equipment that was developed basically 60 years ago to move concrete from a ready-mix truck through a piece of machinery and pipeline to a location where it couldn't be directly chuted or craned and bucketed. It was a machine developed to expedite production and increase productivity and profitability for you, the placing contractor, and finishing time and just placement time. The placing boom is an extension of the concrete pump for production and the ability to make a faster cycle rotation on building high-rise buildings faster than ever before. Even with concrete buckets being utilized, your pouring rates can exceed almost 6 to 10 times faster through a concrete pump than they can with a crane and bucket.
Yeah. I was reading, I don't know if this is, I guess this is a fact. I mean, I looked it up, that there was 393 million cubic yards delivered in the U.S. in 2023. That's
pretty close. You've probably seen that on the National Ready Mix website or somewhere in that area. Portland Cement Association, they keep track of how concrete and what areas of concrete is placed by concrete pumps, direct shoot, paving wise. They've got categories for all of that. So that sounds pretty accurate.
Yeah, and a good majority of that was probably conveyed or pumped in some fashion.
Correct.
Yeah.
Yep.
So if what's a good place to start, Gary? If we were, I think you were sharing before we hit record about you were working on something for someone that's never done this before. Maybe they've pumped concrete before, but it was for a like a distribution center or warehouse or something, right. And it was just wide open. You can set up wherever you want. You got all kinds of room and everything to get set up to pump concrete. What's the difference between that and when someone says, "Hey, we got a 30-story building that we're gonna do in downtown Indianapolis, and we need to set up concrete pumping operation for that"? What's the difference between those two things?
Well, but most high-rise construction is built what I call sidewalk to sidewalk. You may get an additional city street lane and whatever distance you may have between where the curb line ends and the building starts. In a lot of cases, you can't set up big sticks that would reach very high up in the building. So a lot of contractors will start looking at a placing boom, because you can put a boom on top of the building, either a trailer pump or a truck mounted placing boom. There's a couple different applications, and basically limit your foot space to whatever your pump size is, and 2 ready mix trucks behind the pump, which could generally be put between the building and the 1 or 2 streets that the city may give you to build that building. And what that does for you is gives you the opportunity to build the building quicker, because you don't have to disrupt large surfaces, which kind of goes hand in hand with tower cranes. Tower cranes have become a very efficient tool to use in high-rise construction versus a mobile crane that possibly could be big enough. They put that tower crane either right next to the building or sometimes in the building to build the building as big as it needs to be, footprint-wise needs to be, and then take those tools out at the end of the job. So it's a very fast and efficient way to move concrete without taking up much of a footprint. The pipeline stays permanent where it's set. The pump either sets there or moves in and out every day. It can be done a couple different ways to alleviate or open that side up for other activities if you're not pouring back-to-back days.
Yeah, so we probably should describe what a placing boom is, what that looks like.
Okay. A placing boom, we've all seen concrete pumps on a job site, and that's the boom itself. If it's a truck-mounted detachable placing boom, which every brand and manufacturer has some form or fashion, and they start around 28 meters and go up to about 41 meters, about as big as what you can put on a concrete pump and placing boom combination. And it has a quick disconnect tower that comes off of the boom, usually 4 to 6 pins. You knock those out, you pick it up with the tower crane, set it up on what we call tubes or towers, and depending on the job site, you could see as many as 1 to 4 or 6 towers that this placing boom can set on, depending on the size of the building. And it has 4 picking eyes on top of the placing boom that lifts off the truck, sets on the tower with those 6+ pins, puts it back into place. Your pipeline connects through the base of the placing boom and then hooks onto the pump that you got setting on the ground, whether it's the truck mount or a high-rise trailer pump. And away you go. You're in business. And most of the time that can be done in about 30 minutes after you have all your towers set in place. It's a very quick process. If you use just one placing boom and you have multiple towers, you can generally move that placing boom from one tower to the next in 15 to 30 minutes max and be ready to pump concrete if it's a multiple tower. And there are placing booms that are big enough to cover the entire job, depending on how you start your job. They do make what they call DVM placing booms with counterweights, just like a tower crane uses a similar tower setup that sets inside or outside the building and gives you much more reach. I personally used a 42-meter DVM back in the 80s to do a building that set in the center and was able to completely encompass the entire building from one location, which made it very simplistic of pouring, because you could do a deck in the morning, swing right off that deck and do the vertical work on the opposite side. So it does increases productivity and form cycles, deck cycles, just for how fast you can pour concrete versus a crane, the old traditional way of a crane and bucket.
So it pokes through. It can, like you said, it can be set outside the building footprint, or it could be inboard, meaning you would have to plan for openings for it, just like a tower crane, correct? But
correct.
Smaller scale.
The majority of placing booms are put inside the structure, just because we use the structure for the supports of the tower, the placing boom tube, and depending on the type size, you may need 2 to 3 decks, depending on deck heights from one height to the next, in order to offset the kip load, which is the forces that the placing boom puts on the tube and the deck when it's fully deployed. So those things would have to take into calculations when you pre-plan the job with the contractor, the engineer. That's a DVM of some kind. It could be as much as a 42 by looking at it, because it's got counterweights behind it, 4-section boom. But that one's still inside the footprint of the building there. And of course, when you look at the pictures that you're showing below that, there's freestanding towers as well. And sometimes those have to be held off with guide cables or counterweights off the bottom. That particular picture there shows a counterweight base frame that the tower is held upright by building a tower with legs on it, and then they set concrete counterweights on each side of the leg for the counterbalance of the crane of the placing boom without a counterweight. The picture down here in the lower left where you see the counterweights on it, that one there, yeah, click on that one.
It's for sale.
Yep, there you go. That's a counterweight. That's what they call a DVM. A DVM is can't be mounted on a concrete pump because of the massive size of it. The DVM that I used, the head section, which is where all the hydraulics and the main controls were at, weighed 25,000 pounds, which usually is the max of most picking cranes at the furthest point. So when we did that particular place boom setting, we had 3 picks on the counterweights and the basket, a pick on the head section, and then a pick on the other 3 sections, just like you're showing there, broke apart and then put back together. That shows how they split the boom for weight distribution, because the DVM will exceed the picking weights of tower cranes, so they break the main section in 2 pieces to reduce the weight. And of course, the manufacturers have gotten smarter over the years. more engineering defined to meet with picking capabilities to where they now have what they call a power pack that sits on top of the tube, which is separate from the placing boom, which allowed them to build a bigger placing boom and still be able to pick it with the tower crane. So they set the power pack section on top of the tube, get it hooked up, and then fly the placing boom set on top of the power pack, hook everything up, and they're ready to go to work.
What are we talked about the benefits of the placing boom? What are some of the cons? Like, what are some bad things about using a placing boom?
What I find is a lot of contractors have already bid the job and they haven't figured out how they're going to pour their concrete. And all of a sudden, project manager or maybe the superintendent says, well, let's get a placing boom. Well, when they start factoring in the cost of putting a placing boom into play, it usually blows their budget. That's always, to me, been one of the cons. Or they don't understand what it takes to put a placing boom into play. Like I said earlier, if you're having the deck to support it, you need 3 decks poured in place before you can even start with the placing boom. So if you have no access with a big boom to build your lower structures, then you might be doing place and hose, or they'll come up with the tower that you showed earlier with the counterbalance. Well, let's use this. Well, when you find out what this costs, if your pumping contractor doesn't have one in their arsenal as far as tools to use, then you either have to purchase it and sublease it back from them, or come up with a plan to buy it and put it into play. Or the other thing that you can do is put a base in concrete like a tower crane and pour it in place, and buy a section boom that goes in with your re-steel, and that becomes a cost. One of the things, if you have to build a base mat for the placing boom to set on, those costs can range from $50,000 to $60,000 very easily for the amount of concrete, the re-steel, the engineering that has to go into it to make sure that your soil stabilization will support the load of the bending movements of the tower, to where it doesn't move underneath your pad, or your pad has to be built big enough to accommodate those kind of movements. So those costs come in, and then all of a sudden the placing boom may not be the practical tool. The next thing I've found out that contractors thinks a placing boom can be utilized at the same cost that a mobile concrete pump on lower applications. And because of several of the things that I just talked about, they drive your per unit cost up significantly. However, if you're going to keep that in play for another 30 stories, let's say, those costs come down because you are able to write those costs over the course of the time and the duration and the yardage that you pour. It becomes more cost effective. So placing booms aren't always adequate for what I call short buildings, 8 to 10 stories, unless you have no footprint on the ground to utilize a bigger boom truck to pour everything from a truck mounted pump. It's not that it can't be done, but your cost per cubic yard is significantly higher in that starting moments for those kind of structures. Does that make sense?
Yes, sir. Yeah.
Okay.
And then we probably should talk about the safety aspects of it as well. So there's some planning there. It's essentially like having another crane on the site too. So you got to talk about. Can we talk about that as far as
Sure.
what planning you need to do for that?
Correct. One of the critical parts of placing boom applications is the clean out process, like Seth said. everything has to be orchestrated and planned out well in advance, uh, and things need to be taken into consideration. Like you have to have an air compressor big enough to generate enough air to push the concrete out of the pipeline back down in some type of a containment. And here's the problems that tend to happen if you don't go through the planning process. They fail to put the air compressor on the deck, and the crane's tied up when you're poured out. They failed to start the compressor before the pour is completed. They failed to check the compressor to make sure it had diesel or gas in it before they tried to start the compressor. A lot of the concretes that are poured today in high-rise construction have a very fast setting time, uh, because of the lack of water in it. So the hydration process is very quick because they're trying to get that 65 to 70% strength utilization so they can pull tendons, pull forms, whatever that case may be. So the lack of that particular planning application could cause you to lose your pipeline, which could cause a couple days of delay when you tear the pipeline out and put it in. So those have to be well planned out. And the next thing after you get your compressor started, now you got to blow the pipeline out safely. And that takes two well-trained people that understand the blowing concept. The ACPA stresses that the placing hose should be taken off of the boom. You don't want that on the boom. I fight that issue with some people because they want to be able to leave a double-ended hose on the boom so they can just hook up to it, but that creates another safety hazard. By taking the hose off, when you're blowing, if the hose is weak, the cords are stretched, you could actually blow the hose up like a balloon while you're trying to blow the line, and now you've created an explosion. That's why we want the hose taken off. So you have to use the proper blowout cap, which is an inlet and an exit. The inlet is 3/4 inch, and it's got a bleeder valve of 2 inches on the side of it. So if the line doesn't properly blow, you can empty the air out before you take the cap off or disconnect from the placing boom. But let's say that we're blowing the placing boom. There is a correct procedure on how to do that to minimize segregation or dropping of concrete. And this is kind of the sequence that you have to follow safe-wise. The people on top will introduce the Go Devil. Some people still use sponges. A Go Devil is an apparatus that'll push all the concrete and wipe the walls of the pipeline as it goes down. They will actually energize the pipeline before the operator down on the bottom switches what we call a diversion valve. The diversion valve will take and divert the concrete that was where the valve opening was connected to the pump and switch it to the blowback line. And the blowback line has to go to a designated safe area. So once they've energized the pipeline, they'll tell the pump operator to throw the diversion valve. That's a hydraulic valve that he manually grabs a lever and the valve switches from one port to a different port, and then the concrete goes through the blowback line. Operator / labor down on the bottom, while they're hooking up the air, they have to have a slurry mix of some kind, either Portland cement or a commercial grade slick pack of some kind, and pour that in a priming port to lubricate that line. So when the valve switches, the concrete will go through into the discharge line, and that grout or slick pack will lubricate the line as it goes back into either a controlled hopper, a dumpster of some type. Most commonly, it's blown back into a ready mix truck through a vertical pipe that goes up and discharges back into the ready mix truck, so you don't have however many yards of waste coming out of the pipeline on the ground to deal with. And then the ready mix supplier can take it either back to the plant. Sometimes if you use a straight cement, they can use it maybe in some part of the pour in a different location. So when that concrete is moving through the pipeline, the operator has to be listening on the pipe or tapping on the vertical and the riser pipe at the thrust block where it comes out of the building to listen where it goes from a hard sound to a dinging sound. And with communications, tells the people up on the top to either shut the air off or start bleeding the air, because you don't want the air compressor to run wild, as I call it, because if you do, it's not uncommon for the energies created from that air moving the concrete through the pipeline to physically pull the pipe out of the ready mix truck, break the chains, and now you have sprayed concrete all over the city streets or the building next door or whatever, because you didn't release the air that you've generated over 2, 3, 4, 5, however many hundreds of feet that you're pushing through. And that's where that training comes in, to where the ground man says, stop air, hold air, and let the air expand and see if it continues to push. If it continues to push, then he may give the command of drain air on that 2-inch valve. You open that up or crack it and take off some of that air pressure, because the idea is to have a minor explosion, not a major explosion, because when it becomes a full blast, we had that happen just a couple days ago, where we broke the chains that were tied onto the ready mix truck because they forgot to bleed air and broke the chains, and concrete hose come whipping up out of the drum and showering concrete all over everybody. Fortunately, nobody got hurt, but it could be a disaster when stuff like that happens. I can tell one funny story. It didn't happen to me, but they didn't bleed the air, and they didn't have the chains hooked up right on the ready mix truck. This was downtown Indianapolis, and the pipe and hose came out of the ready mix truck, shot through the back windows of a Cadillac, and an old lady who just had her hair done was sitting in the front seat. When they went to check on her, she was kind of like in a frozen moment, like what the heck just happened. It destroyed her Cadillac, because between the puck marks all over the outside and concrete inside the interior, and this woman terrified to death. Wasn't my job, it was another contractor, so I can laugh at it, or because of the incident, because no one got hurt, but that could have been just as easy 2 kids in the back seat. And that's part of one of the downsides. The safety of people that don't even work on the job site can be hurt during the blowout process if you've not done all your training properly, have your securities put into place, and things like that.
Yeah. Yeah. Serious business for sure. So we talked about the, what we should touch on, Gary, is the mobile versions of placing booms. So spiders and things that we need to look out for. So let's explain what one of those are.
Those are unique to the market. They've probably been out about 6 or 8 years, and there's a few different manufacturers that have brought them into play. Some of them are kind of fixed. They have to be moved around by either fork trucks, small cranes that can be lifted into devices. There are some that actually are on hydraulic crawling track packs, and most of the booms will range between 15 meters and 18 meters. And they're very efficient, especially in bringing foundations out of deep holes, where they put in lagging boards, and you've got foundations that are deep, and your 40 meter or your 58 meter, your 60 meter concrete pump can't reach all the poor areas. This one here is sitting on a deck.
That's a messy deck.
Huh? Yeah.
That's a mess of a deck.
That's a mess. And they are heavy. That's one of the drawbacks. And it's not that they can't be used, but they weigh in the 18 to 20 plus thousand pounds. So wherever those legs land, you have to make sure that the deck can hold the weight, or the shoring has to be underneath it. This one here is one that if I could buy one and had a job for it to go on, I would buy in a minute, because it can be used 2 different directions. It has 2 power packs, one that runs a placing boom and one that runs the crawler part of it, the track part of it. So you can take it inside of, let's say, inside a facility, manufacturing facility where you're doing foundations or pit work inside where you can't get a concrete pump inside, just run your pipeline to it, and then you still have a boom to pour your work without dragging hose. And it's not ours. We subleased one through a pump contractor to one of our general contractors up in South Bend, just like that. And we couldn't use a boom truck because of where the concrete had to be poured. We ran 400 feet of pipe, and the operators inside the facility where the concrete has to be poured, and then we got a pump outside going through the pipeline, and we poured foundations and vertical work as well. So it's a very useful tool for the right job. And there's more than one manufacturer now. If you go to World of Concrete, you'll see a couple different manufacturers. And one of these days, I'll see a job coming for R.L. McCoy that would justify the expense. Right now, like I said, there's people out there that own them. We sublease one for one of our contractors to do a job just like that. It's a very useful tool. Again, for the right project, it minimize all your labor. You can do, that one. I don't know what size that one is, but the 18 meter, which is about as big as they've made them so far because of the counterweight capabilities and the overall weights, that's 60 feet. So that gives you 120 foot of reach. And when you can get right next to what you're doing, that's a lot of surface area that you can cover with a machine like that.
Yeah, that's the first time I've seen one with the tracks on the bottom of it like that. I was wondering what that was for.
Yeah. I've known some jobs in the past. We do a lot of automotive work that back 20 years ago when we were revamping the Chrysler building in Kokomo, they were turning everything over to robotics, and they were putting all these pits and trenches and stuff inside the building with a 12-foot ceiling height that you couldn't do anything with other than pipe and hose. There were some tired laborers by the time we got done because this particular type of machine wasn't available yet. But they'll catch on, and as they build more of them, hopefully the price will come down to where it'd be a tool that you could have in your arsenal.
Yeah. How much does one of those cost?
Last price I looked at them, they were around $200,000 for the crawler.
With the one with the crawler on it.
Yeah.
Yeah. I think you touched on it, but I think we should emphasize the if you are using them on a building to ensure that you're reshoring underneath.
Right. That goes back to your engineering. Anytime you're putting anything into a structure of any kind, whether you're using laser screeds on top of a deck, a placing boom, a spider like this, or the old type spiders that were just all mechanically operated, which are much lighter but not as mobile. All those have weight loads, and your engineer gives you a sheet of the manufacturer of point loads of your outriggers on whatever surface they come in contact with, and they'll tell you how much pressure loads have to be supported under each one of those legs, and it can easily be done with additional towers put into place with 4x4s on top of it, and you may have to do more than just the floor below it. Below the deck that you're pouring, you might have to go 2 floors below, depending on the type of concrete structure you're setting on, that the decks may not be able to support those kind of point loads directly without additional support. So all that has to be done in the planning, because you don't want to set it on a deck and then something fails underneath because you didn't plan ahead for the weight loads. And that's one of the things. I've got a sheet that I keep when I do any kind of a pre-job with a contractor, that I'm going to give you the specifications and the weights and the locations of where you want to do the project, and then you have to take that information to the engineer of the building, and then the engineer of the building tells the contractor what spacing of shoring, how far down he has to shore, how many shores have to be into place to support those loads. And it's all drawn out, and the engineers will generally give them a layout of the building, layout of the forms and towers that they put in, because in today's world you got these aluminum towers that are really easy to put in place. and you go underneath them and crank them up with what the 4x4s or whatever it takes to hold the concrete up. But that needs to be done in conjunction with building the deck, and those spots have to be planned out prior to re-steel or post-tensioning cable to make sure when you land those feet, there's a mark on the deck that where each foot goes, so you know you're directly over the forming or the reshoring and in the right spot of the deck, because you don't want to set one of those feet on a deck that's not supported, because it'll punch right through a wood deck, and then you have a real safety hazard to deal with.
Yeah. All right. Was there anything else that you wanted to touch on before we stop for today?
Basically planning. Even if a contractor has done placing boom work in the past, I have a sheet. If anybody is interested in, they can reach out through you, Seth, and come to me. It pulls it. You can see this, a complete sheet here of all the different things that needs to be discussed between the pumper, the contractor, the general contractor, who's in charge of hoisting. Talks about all the different areas. So when you're in the planning stages, you cover all these things, and you don't get to the actual construction stage and somebody says, well, who's going to provide the cleanup, or who's going to provide this, or who's going to be responsible for that? And then it becomes an uncomfortable conversation because it wasn't discussed prior to. And every one of these items that's on this sheet has a cost. Some of them aren't so significant. Some of them are just, for example, communications between the deck and the operator. That's an extra radio that somebody has to have. Grout to prime the pump. I thought you could do it with slick pack, for some people. No, I got to have 1 or 2 yards of 9-bag grout that costs $300 a yard. Those kind of conversations need to be had in the planning stages, and preferably in the bidding stages. So if you're bidding a job and you think you want to put a placing boom into play, then you need to cover these costs with your provider to make sure that you're not on the short end of the stick, or there's a lot of unhappy feelings at the end of the day. And I've ran into about every one of these, and one of the things that always comes up, if it's not a conversation, is who's going to provide the 483 phase to run the power for the placing boom. And we got on one job, and the city couldn't provide the power.
Uh-oh.
Initially.
Yeah.
And so there was this big discussion who was going to pay for the power company to redo whatever they had to do to get that extra 483 phase to the job, because they only planned for 2 tower cranes and they forgot the placing boom. And it was a pretty heated discussion because, here we got all this equipment coming in, but we don't know how to use it. And that's what this safety check sheet that we put together covers, all those kind of things. So in the discussion era, you'll discuss it, because Indianapolis has a lot of places downtown that 483 phase is hard to come by. I was working for Wilhelm Construction. We were at the VA hospital. We had a placing boom into play, and that was one of those processes. They had 2 tower cranes, and the placing boom came into play, and they didn't have enough power. So the electrical contractor went to the VA hospital, because we was building an addition to it, and figured out a way to pull power out of the panel from the hospital. Well, that all worked out real good till about halfway through the project. At 4 o'clock in the morning, we fired everything up, and we blew a fuse about the size of 2 fists together. Half the hospital went dark, and the whole job site went dark.
Oh.
Now we're talking a hospital, okay?
Yeah.
Over a $20 fuse or whatever it was. But that was one of those things where probably planning prior to that, putting the placing boom into play. I don't know all the details because I was just a pump operator back then, but some planning prior to that may have prevented that particular incident from happening, and so they had to come up with a counteraction to that. They had to have an electrician on staff anytime they were working outside their normal hours, and fuses by the fuse panel where they could put a new fuse in place. So those are things that you got to take into consideration, and of course, we all know the more you plan, the less you fail. And placing booms to me is a lot of planning, and they can be very successful. They can be very productive. You can have very good unit cost on high-rise construction. Once you get through the lower cases, your poor cases. I had a 32 DVM. I want to share this story real quick. I was working for Hubert Hunt and Nickel. We were on the 9th floor, and they'd lost 3 days of production because the wind was so high that they couldn't do a lot of hoisting. The material back then, we built the decks in place. The material was there, so we were able to continue to work, but the tower cranes couldn't swing. And so after the third day, we ended up the project concrete superintendent company says, "You think we can pour about 1,000 yards today?" And I said, "Well, it's going to be a long day, but yeah, we can do that." I said, "Why?" He said, "Well, we're going to start on the 8th floor, pour the deck, we're going to swing around," and we had this DVM 32 meter, pour the 9th floor, and then swing back and pour all the vertical work on the 8th floor before the end of the day. And about 14 hours later, we were walking around and caught back up in production because of what a placing boom can do for you. If they'd had to try to make up all that time with tower cranes, they would have never made it up, because tower cranes have to stop running at 25 mile per hour. Placing booms can generally run up to 30, 35 mile an hour. So sometimes a placing boom can pour when a tower crane can't. Now, you stretch your luck if something goes wrong with a placing boom and you can't swing the concrete, but that's one of the advantages of a placing boom.
Huh. Well, I didn't know that one, so that's a good one to know.
So, I've had a few stories. I love placing booms. I started chasing them back in the 81, 82 when I first got into it, and that was about when I know Schwing, sure Putzmeister and the other contract pumps weren't available, but that's when the placing boom started coming into play and literature started coming out. Put my first placing boom with Cross in 84, and that was with Wilhelm. And then shortly after that, I was able to use that DVM 32 with Hubert Hunt, and then I ended up taking over that job after I moved on from there. And they always fascinated me just because of the productivity, the ease of concrete placing. You don't have to have 2 guys on the ground catching a bucket. You don't have to have 2 guys on the deck catching the bucket. I went to Chicago back in my early days, and I timed tower cranes, and a 2-yard bucket on a tower crane to the 30th floor was a 16-minute round trip for 2 yards. We had an issue, and this is another thing about a placing boom. We had a breakdown on the JW Marriott back in 2010, and it took us about 2.5 hours to fix the pump. Well, they craned the concrete while I was fixing the pump. In that 2.5 hours with 2 tower cranes, they craned 60 yards. And we ended up putting the pump back together and finishing the last 100 yards in about 45 minutes or an hour, whatever it was. Mm-hmm. So that's the advantage of the concrete pump. It saves time, it saves money. It does create some safety hazards with proper training and planning. It's just another useful tool to use in concrete construction.
Oh, that's a perfect close. Gary, if folks want to reach out to you and learn more about concrete pumping or RL McCoy, what's the best way?
I'll give you my cell number, 317-442-7401. That was 317-442-7401. I won't answer it if you're in my not in my phone book, but it says leave a message and I will call you back. And I do. I call everybody back, whether it's safety related, concrete related, mixed design. I'm happy to share whatever information I can with anywhere, or you can email me at garybrown@rlmccoy.net. That's my email.
Take advantage of that, folks, or you can reach out through me and I could get it to Gary as well. Gary, thank you for coming back on the show. It was a pleasure. And folks, until next time, let's keep it concrete.
Thanks for joining us for another episode of the Concrete Logic Podcast. If you got value from the show, here's how you can provide value back to support the show. Visit concretelogicpodcast.com and click the donate button to send value back. All dollar amounts are truly appreciated. And now, to close out the show, here's Mike Dunton.
light, put some diesel in the lights and wait till the trucks roll up. Yeah, this ain't how most folks live their lives, dripping in sweat, working overtime. But while they're tying their ties for their 9 to 5s, we're out here changing